The middle school students at the Boys and Girls Club spent 4 weeks with our group using physics, math, and engineering design to put together racers out of recycled materials. We used the Engineering is Elementary Go Green Recycled Racers curriculum to prepare our 4 lessons. The overall learning objectives were for the students to understand how to reduce friction, mass, and other hindrances to improve the overall design of the car. Design a recycled racer that traveled a distance of 20 feet and or traveled the fastest. Use AudioNote to record improvements made to the recycled racers. Use the Speed app to calculate the velocity of the recycled racers. Learn to enter speed and distance data into the Recycled Racer Challenge website to track the racer's progress. Students were asked to use a variety of science, math, and engineering techniques to improve on their racer designs and make the fastest racer possible. Each student was responsible for building an initial model, listening to basic design presentations, and taking constructive feedback in order to make the necessary improvements to their designs. The students also used the Speed app on the iPad to calculate the velocity of the racers and kept track of their design changes in AudioNote. Students entered the data collected onto the Boys and Girls Racer Challenge website that was designed by our group. Student success was assessed based on racer speed, the distance the racer traveled, overall design, ingenuity, perseverance, teamwork, communication, and effort.
An example of a challenge a student faced and overcame took place on our last day at the Boys and Girls Club. The student had begun working on his design the week before and was ready to test his recycled racer. At the start, his racer was not going anywhere. He tested the wheels and found them working. Then he tried it again and realized that the balloon was obstructing the wheels from turning. He added flashcards as fenders to prevent the balloon from touching the wheels. After making such modification, the recycled racer was able to achieve the farthest distance from the group.
Students learned a number of different things with regards to the project. What was great about this project was that each student can kind of take what they wanted from it and use that and apply that to their racer design. We focused a lot on speed, time, and distance, so we did talk a lot about how to improve overall speed by reducing mass. So we talked a little bit about Newton's laws of motion. We also were able to get the students hooked with the iPad system and the AudioNote app. A lot of the students did not have a general understanding that an iPad could be used as a educational tool and a resource and a way for students to take notes and kind of communicate with us. So overall, those were some of the things that the students learned. From the beginning, we really wanted to have the students understand that this sort of engineering design, problem solving, is actually something that they do on a regular basis. It's something that they've done since they were very little. Solving problems to get a result that you want and continuing to work on something if it doesn't work initially. I think in every person's job ever, regardless of what it is, they've had to do some sort of problem solving, and that's really what we wanted to show the kids. They constantly would challenge themselves and be like, no, I think I can do better. And when you kind of posed that to the kids, they really kind of opened up and they really kind of lit up about that they wanted to do better for themselves. And I think that's the one thing that they can really take away from this, is that if they apply that type of stuff to anything that they do, that they're going to find success.